Hello guys, welcome to my channel. This is Uday Pandit and you are watching MEP Technical World. In this video, we will learn about DOL Starter wiring. Basically how to do DOL Starter wiring. Okay. In previous video, I have already discussed about basically how to read the DOL Starter wiring diagram or drawing, and even how to make the DOL Starter wiring diagram. So if you are still not watch that video, so please watch that video will be helpful for you to understand this video. Okay, so I'll give the link in this description box. So before I start the session, I would like to request you, if you are not yet subscribe my channel, please subscribe my channel and also hit the bell icon so you'll get notification regarding my upcoming videos. So let's get started. So first we'll do power wiring. Okay, then we'll move to the control wiring. So basically in power wiring, so this is the bus bar. Okay, TPN bus bar. Here we have a 3 phase and 1 neutral. Okay, and here we have a TP MCB. Okay, then after that we have a contactor. Okay, 3 phase contactor. Then after we have a thermal overload relay. Okay, then finally to motor. Okay, so in this way we can do the drawing. So during the wiring, first we have to keep a drawing with yourself, or before you start the drawing you have to understand the wiring diagram of this DOL starter. Okay, so in this fashion, according to the drawing, we have to wire the DOL starter. Okay, so first let's take the components, actually DOL starter components for power wire. Okay, so for that first let's take a main MCB. Here I have taken main MCB, which is TPN. Okay, 3 phase and neutral type, and then again here we have taken 3 pole MCB. Okay, this is the main incomer of panel, DOL starter panel. In one panel we have a 2 set of DOL starter. Then usually we put one main incomer MCB or MCC. Okay, that's why I have taken this one, and this one, which one is triple pole MCB, is separate for one starter set. Okay, so here I am going to explain only one starter. Okay, and this is the TP MCB, and this one is the contactor, and this one is the thermal overload relay, and finally this one TB, which one, this is the TB terminal block, and finally we have a motor, 3 phase induction motor. Okay, so here power wiring we have arranged all the components, including MCB, contactor, thermal overload relay, terminal block, and 3 phase induction meter. Even to measure the current and voltage, here we have taken also voltmeter and ammeter. Okay, first let's complete the wiring of main incomer. Okay, so here we have a supply source. Okay, so this is 3 phase TPN supply source, 3 phase neutral. So here we have a source. This might be coming from LT panel. Okay, so this is the source of 440 volt. Okay, now from here we can connect the 4 wire at the input terminal, for R phase, for Y phase, for B phase, for neutral phase. Okay, now from here let's take a wire or bus bars. We can say this one is bus bar, this one is for red from the output of this MCB, and this is for Y phase, and this is for blue phase, and this is neutral one. So here we have a now 3 phase neutral bus bar. Okay, so RYB phase is present over here and one is neutral. Okay, so now up to here, hope you guys have clear about main incomer wiring. Okay, now finally let's come to the power wiring of this DOL starter. Okay, so first we will complete the wiring for this TP MCB. Okay, so let's take a wire from this bus bar R, from Y, and from blue, and it is connected at the input terminal of this MCB. Now from the output terminal of this MCB, it is connected to the input terminal of this contactor. Okay, so here we have a terminal like L1, L2 and L3 for 3 phase. So from the output of this MCB, it will connected to this input of this contactor, which is at L2 and L3, all 3 phases. Okay, now here a terminal side of this contactor, or we can say output side of this contactor, will connect thermal overload relay. So this is the thermal overload relay for protection. In case we have a motor is overloaded, at that condition this will trip the whole circuit. Okay, so it will protect the motor. So this is for protection, thermal overload relay. So it has a pin at input terminal. So this pin will, these three pin, okay, will inserted in the output terminal of this contactor. Okay, then we will tight the screw. Okay, first loose the screw with the help of a screwdriver, then we will insert into that, and then again we will tight the screw. So this thermal overload relay will be at output side of this contactor. Now finally, from the output terminal of this thermal overload relay, it is connected to, wire will be connected at terminal block input side. Okay, this side RYB. Okay, now finally from the terminal block of output side, output terminal, it is connected to the 3-phase induction motor. So this is a 3-phase induction motor. Here we have a terminal box, so here we can make the delta connection. Okay, so here we have a some kind of like this type of terminal, and there are a strip, so 3 strips, so we can arrange this strip in this fashion and directly connected to over here. So in this way this motor will be connected in delta. So finally from the output of this terminal block, it will connected to the 3-phase induction motor. Okay, so in this way we can do the power wiring of this DOL starter. Okay, now let's come to the main incoming indicator wiring. So to monitor the 3-phase line, we have to install 3 indicator for 3 phase, like R phase, R color indicator, red color, and for Y yellow color, and for blue phase, blue indicator. So here we have taken 3 indicator for 3 phase. So this is for only monitoring purpose, whether our 3 phase supply is available or not at our incoming terminal. Okay, so here we have taken, so individual indicator for individual MCB, here we have it, so we have kept here. Okay, now for this, for this red, so we have to take R phase from, we have to take a wire from this R phase, and it is given to this red indicator. Okay, for Y phase, from Y bus bar, let's take a wire and connect it to the input terminal of this MCB. This is a single pole MCB, and from the output of this, it is connected to the yellow indicator. Okay, now from blue indicator is connected to the input terminal, and from blue bus bar, let's take a wire and connect it to the input terminal of this MCB, and from the output of this MCB, it is connected to the this bus bar, this LED indicator, blue indicator. Now all indicators got phase, okay, RYB, but this also need neutral to glow. Okay, that's why I have taken neutral wire from this bus bar, and it is given to all 3 indicator. Okay, so in this way we can wire the indicator, phase indicator bulbs. Okay, now finally, so basically when all phase are present, means R phase are available, it means it will be glowing. If the Y phase is not present, it means this bulb will be, this indicator will be off. Okay, if the all phase, all 3 indicator is glowing, it means all phase are present, 3 phase are present, R, Y, B phase are present. Okay, so this is for monitoring purpose. Now come to metering section. Okay, now to measure the current, here I have taken ammeter. Now for 3 phase, we have to measure the current for individually. For 3 phase, like R phase, how much current is going on inside the, how much current is drawing from R phase, Y phase, and B phase. For that, we have to install, we have to fix selector switch. So here we have a 4 position selector switch. Okay, so 3 4 phases and one at off position. Okay, similarly for voltage, to measure the voltage of the system, so here I have taken voltmeter. Okay, and to measure the all three phase voltage separately, here I have taken 7 position selectors. Okay, actually with the help of this selector switch we can get the reading, or we can measure the voltage like phase to phase, line to line, okay, and line to neutral, phase to neutral also. Okay, so with the help of this selector switch we can select the phase to phase voltage or phase to neutral. Okay, now let's wire this meter with the help of this selector switch. So first, here in this selector switch we have a terminal available for R, Y, B. This is from back side. Here we have a terminals and A1, A2. Okay, and similarly for this voltage selector switch, so here we have also R, Y, B and neutral terminals available at back side here. Okay, so first let's complete the wiring of this ammeter with this selector switch. So let's take a first R phase, and it is given to this R terminal. Okay, now from Y phase let's take a wire, and it is given to this Y terminal. Okay, now let's take a wire and blue wire and given to this blue phase terminal of this ammeter selector switch. Now from the A1 and A2 terminals, let's take a wire and connect it to the plus terminal of this ammeter. At the back side of ammeter, where we have a terminals like plus and minus. So at plus we have connected A1, and at minus let's take a wire and connect it to the minus terminal. Okay, in this way we can wire the ammeter through this ammeter selector switch. Okay, now come to voltage wiring, voltmeter wiring. Okay, through this selector switch. So for that, let's take a red wire from here, because it is already over here R phase. So from here we can loop it. So for Y phase, here we have connected. Now for red phase we have connected. Now for blue phase we have connected at RYB terminal of this voltage selector switch. Now from here let's take a neutral wire, okay, and connect it to the neutral terminal of this voltage selector switch. Okay, now from here we have an option V1 and V2 terminal. So from here we can take a wire and connect to the V1 terminal of this voltmeter. Actually backside of this voltmeter we have a terminal V1 and V2. So we can connect V1 at V1 side and V2 at V2 side. Okay, in this way we can wire the ammeter and voltmeter with these selectors. Okay, so actually if we want to measure the current of R phase, then what we have to do, this selector switch is rotate towards the R side. So if we rotate it towards the R phase, it means this ammeter will show the current reading of R phase. If we Y, then B, then B. Okay, at 0 position it will be off. Okay, now for voltage selector switch, here we have a 7 position selector switch. If we put phase to phase, means R to Y. Okay, if we select it or rotate towards this side, it means it will show the phase to phase voltage, means 440 volt over here. Okay, so near about this. If we select R to neutral, means between R phase and neutral, phase to neutral, how much voltage will be there. So it will show around this 230 or 240. Okay, so in this way we can get the voltage reading or current reading from this ammeter and voltmeter with the help of this selector switch. Okay, up to here we have completed power wiring of DOL starter. Okay, now let's move to the control wiring of this starter. So in control wiring, here we have taken 220 volt source, which is AC. Okay, so red one is phase 1 and black one is neutral. Okay, suppose this is the bus bar, and here we have taken thermal overload relay, and this one is contactor. Okay, actually this thermal overload relay is over here, but to make simplicity to understand easily of this control wiring, I have kept it. So I have placed this thermal overload relay over here. Okay, so this is not a big issue, and this is the control MCB Okay, control wiring MCB single pole, and this one is NC push button to stop the motor, and this one is NO push button to start the motor. Okay, and these are the indicator. This will indicate the start. Okay, if our motor is in a start condition, it means this will glow. If our motor is in a stop condition, it means this will glow. If the motor is in fault condition, okay, in case of overload condition, overcurrent condition, this red indicator will be glowing. Okay, so these are the components for control wiring. Okay, now before start the control wiring, again we have to understand about the control wiring diagram, actually drawing. So here in this way actually this will work. So first we'll take a power from MCBs. This is single pole MCB. Then it will goes to NC contact of this NC contact of thermal overload relay. Now from there it is goes to NC push button. From there it will goes to NO push button. Now finally to contactor coil A1 and A2. At A2 side we have given neutral supply. Okay, we have a phase, and at A2 side we have given neutral supply. To hold the contactor, we have to implement the holding circuit. So from here use NO contact of contactor. Okay, so in this way we can. So first we have to understand about control wiring, then we will move to the control wiring, basically how to do wiring of this DOL starter. So let's start the control wiring. So first let's take a wire from this phase wire. Okay, and it is connected to the MCB single pole at the input terminal of MCB. Now from the output of this MCB, it is connected to the NC terminal of this thermal overload relay. Okay, here. So these 95 and 96 are the NC contact of this thermal overload relay. So from the output terminal of this MCB, it is connected to the 96 number of this NC. You can also connect it 95, and from the 96 we can take output. So here I have connected it 96 at input. Now from the output, which is 95, let's take a wire and connect it to the NC push button, input terminal of this NC push button. This is for stop the motor. Now from the output terminal of this NC push button, it is connected to the input terminal of this NO push button, which is used for start the motor. Now from the output terminal of this NO push button, it is connected to the A1 terminal of this contactor, which is coil terminal of this contactor. Okay, now let's take a neutral wire and connect it to the A2 terminal of this contactor. So here A1 terminal got the phase supply through this thermal overload NC contact and NC push button and NO push button. In this way it will reach to this A1 terminal, and neutral is directly connected to this A2 terminal. Okay, now up to here actually what happened, if we press it, okay, to start button, so contactor contact maker, so contactor contacts actually make the contact. Okay, so it will start the motor. Okay, when we are pressing, if we release our finger from this, again this will be off. So this is actually we do, so this is actually we don't want. We want when we press it once at the first time, at that time this starter should be permanently hold. It means it starts the motor permanently even we release our finger from this push button. So to make that, what we have to do, we have to implement the holding or latching circuit. Okay, so for that let's take a wire from here at the input terminal of this and NO push button, and it is given to the, it is connected to the NO terminal of this contactor. Now from the output terminal of this NO contact, it will connected to the A1 terminal of this contactor. Okay, now up to here we have completed holding circuit also or latching circuit. Now even we release this push button, what happened, this circuit will permanently giving the phase supply at A1 terminal. Okay, so that's why we implement the holding circuit. Okay, now let's come to the indicator wiring. So there are 3 indicator, one for start, one for stop, and one for trip. So this indicator will help us to monitor the status of motor. Okay, now so first let's complete the wiring of this start indicator. So for that, let's take a wire from this anode contact. Okay, and it is given to this start indicator. From here neutral will be connected. Now for the stop, let's take a wire from anode contact to NC. So here actually always available power supply, that's why let's loop it from anode to NC. Now from the output terminal of this NC contact, it will given to this yellow indicator, which is used for stop. Okay, now neutral is given from here. Now to trip indicator wiring, let's take a phase wire, because phase is available at this terminal, 96 terminal. So from here we can loop the 98. Okay, so from here now at 98 terminal phase supply is available. Now from 97, let's take a wire and it is connected to the trip indicator, which one is red one. Okay, now let's give a neutral also. Okay, so in this way we can complete the control wiring. If we talk about its working, basically when we press this switch, our motor will start. Okay, motor will start. So at that time what happened, this contactor will make the circuit. It means our motor is in running condition. So at the same time what happened, when we release this NO contact become a NC, that's why this A1 terminal will get a power from this latching circuit or holding circuit, and at the same time this indicator will get the power from this NO contact and this will be on. Okay, so it means our motor is in start condition. Okay, when we press it to stop the motor, then again this will break the circuit, permanent hold latching circuit. It means again this contact NO contact previously it was NC, it means again become a NO when we press this one. So this will be off, and this NC contact actually at normal condition this power will flow like this and it will reach to over here, and this indicator will be glow. So it means our motor is in off condition. Okay, so in case our motor draws as per rated current, or in case our motor is overloaded condition, it means suppose here we have set 12 ampere. Okay, so above 12 ampere this will trip. It means at trip condition what happen, this main power will be disconnected because this NC contact become a NO. So at that time what happen, our motor will be stopped because it break the circuit, contactor break the circuit, and this NO contact become a NC, means power will reach over here and this will trip indicator will be glow in case we have a fault. Okay, so in this way actually our DOL starter wiring, DOL starter works. Okay, so hope you guys understand about basically how to do power wiring and control wiring of this DOL starter, and it's working. Thank you for watching this video. Please like, share, subscribe, and also hit the bell icon so you'll get notification regarding my upcoming videos. Thank you very much. See you again in next video.